All right, guys, welcome to the last new section in Unit 3. Hurrah! I'm sure you're all saying. But after this, there's going to be a good old review, and then it'll almost be test time. So definitely been a long unit, but I'm sure you're doing a great job. Thank you for sticking with me this whole time. Anyway, if we are going to start this last video, you might notice that we have composition of functions, just like the last video. However, if you look at negative 0.87 and 1.2, both of those are not on the unit circle. So the first video we focused on composition of functions with the unit circle, and now we're going to focus other ways to solve these not using the unit circle. And one way that'll come in handy is by drawing a triangle. Before we do that though, if we look at both of these, I'm assuming they're in radians. And it's always good to check at the beginning. These two are ratios, so we want to make sure that our ratios are in the domain or range. So if we look at the negative 0.87 for sine, we're looking at arcsine. Remember, this is restricted between negative 1 and 1. Negative 0.87 is in the domain. 1.2, however, is not between negative 1 and 1, so this is not in the domain. So I'm going to say right now that even though this is a composition function, because this inside part is not possible, the entire thing is not possible. So this does not exist or no solution because there is no answer and we cannot solve. However, the previous problem, if we think about that sine is restricted from negative pi over 2 to pi over 2, or in quadrants 1 and 4, that means to me that the arcsine of negative 0.87, that the angle is going to be in the fourth quadrant. So whatever that angle is, if in the calculator I type in radians, inverse sine of negative 0.87, I would get an angle of negative 1.055, which is in the fourth quadrant. So because negative 0.87, that ratio ends in the fourth quadrant, and because I'm taking the sine of the arcsine, these are inverses, and because this angle is within the restriction, as we saw in the previous video, when you have an angle that's in the proper restriction area, it comes out as the same again. So our answer is negative 0.87 for this one, and it does not exist for that one. I like when this happens, but it has to be in the restriction values, otherwise you may not get in the same quadrant. Now, new types of problems. When you look at the domains of all of these, I checked already. The square root of 5 over 5 is, the square root of 5 divided by 5 is 0.447, so that is between negative 1 and 1, that's fine. Negative 5 divided by 13 is really negative 0.385, so that's in the domain as well for sine. Negative 5/8 is definitely between negative 1 and negative 1 is also not between, but this is tangent, and you might remember that tangent, if I go back, has no restriction. So it seems like on this slide we have no problems with anything we're plugging in, but something strange does happen here. All three of these possibilities, or all four of them, especially these three, are not on the unit circle. So what do? We could use the calculator, like the previous ones, but that's usually our last resort because we usually want answers to be exact. So when in doubt, draw a triangle. And actually, I'm going to be more specific. Rather than just drawing a basic triangle, I'm going to think about quadrants. So I'm going to draw a coordinate plane. And remember, with composition, you start inside out. I think about where is cosine restricted. Well, cosine is restricted, or the arccosine, in quadrants 1 and 2. Because root 5 over 5 is positive, I'm guessing that my little triangle will be drawn in the first quadrant. And if I do that, this is my reference angle of theta. That means that my angle is found by doing the inverse cosine, where root 5 over 5 could really represent adjacent over hypotenuse. So this could be root 5, this hypotenuse could be 5, and this third side could be found using the Pythagorean theorem. So we could say x squared plus root 5 squared equals 5 squared. X squared plus 5, because remember these are inverses, equals 25. So x squared equals 20. If I take the square root of 20, that is the same as 2 root 5. So this side here is 2 root 5. Now, how does that help me actually find my answer? Well, if you think about it, we've symbolized theta now using a triangle. We said that if we know that theta is based off of arc cosine or cosine, this is adjacent over hypotenuse. So now if I worked outside, the sine using the same triangle of theta would now be opposite 2 root 5 over hypotenuse 5, so this is our answer. So interestingly enough, if you draw a triangle, you are representing what the angle would be using these sides, and then you can use these same 3 sides to find the outer part of your composition. Let's try it again in the next example, the secant of arc sine of negative 5 over 13. So if I think about first that sine is restricted in quadrants 1 and 4, because this ratio is negative, I'm guessing that my triangle will be drawn in quadrant 4. Theta here would be my reference angle. Sine is opposite over hypotenuse, so this would be 5 and 13. Because y is negative, it's going to be negative 5. If you do the Pythagorean theorem or use a Pythagorean triple, this side would be positive 12, because x is positive in the first quadrant. So this is being taken care of by drawing the triangle because you're representing what the angle is. Because remember, you plug in a ratio, you get an angle. We don't actually need to find the angle because now I'm trying to find secant of that same angle. So it doesn't matter as much what theta is, it matters more that the triangle is drawn. So secant of theta is really the same thing as 1 over the sine of theta, or so the cosine of theta. So we could find the cosine of theta, which would be 12 over 13. So that means the secant would be the reciprocal, 13 over 12. So these next 2 examples, because this is kind of an interesting way to view it, I would like to give you a chance to try these first. So please pause your video, and I will go through this in detail when you get back. Okay, let's tackle this third one. So we have arc cosine of negative 5/8. Arc cosine is restricted to quadrants 1 and 2. Because the ratio is negative, I'm guessing my triangle will be drawn in the second quadrant with my reference angle right here. Cosine is adjacent over hypotenuse, so this would be negative 5 over 8. X is negative in the second quadrant. If I again do the Pythagorean theorem, negative 5 squared plus x squared equals 8 squared, I would get x squared equaling a lovely answer of 39. And if I take the square root, x is the square root of 39. So I'll try to put that right here. So now that we have our triangle drawn, remember, we don't need to necessarily find exactly what theta is, but this helps us find the tangent. So tangent of that same angle is opposite over adjacent, or square root of 39 over negative 5. So that is my answer. And again, another way to think about it is in here, ratio in, angle out, but then here, angle in, ratio out. Last one of this type, the cosecant of the arctangent of negative 1. What we want to do here is think about that tangent is negative in one of 2 quadrants, 2 and 4, and tangent is restricted in quadrants 1 and 4, so I'm guessing that my triangle is here. Here is my reference angle. Tangent is opposite over adjacent, so that would be negative 1 over 1, this one being negative because y is negative. 1 squared plus negative 1 squared is eventually, using the Pythagorean theorem, would be the square root of 2 for the hypotenuse. So here is my angle. If I want to find the cosecant of theta, you could find the sine of theta first and get that to be negative 1 over square root of 2, which means the cosecant would be the reciprocal, negative root 2 over 1, or just negative root 2. Drawing triangles is fun, guys. I actually like these problems a lot. I think that they're kind of cool. On to the next one. For each triangle below, write theta as a function of x. What this means is you want something, theta equals something over here, all in terms of x. So let's see if we can write an equation. Both of these triangles, theta is what you care about. Back to the first section of this entire unit, if you look at the angle, because everything depends on it, what sides do you have in comparison? Well, even though we have variables, this is still opposite, this is still adjacent, this one is adjacent, and here is hypotenuse. So if you were looking to try this example, you could say to yourself, wait a second, opposite and adjacent, that seems like tangent to me. So that means to me that tangent of theta is opposite over adjacent. Even though we have variables, we can still plug that in. Tangent of theta is opposite x plus 1 over adjacent 10. And my goal is to get theta by itself. So how do we get tangent away from theta? Well, we apply the inverse on both sides. So if you apply the inverse to both sides, theta would be the inverse tangent of x plus 1 over 10. But because we've been using arctangent so much more recently, I'm going to say that a good answer would be the arctangent of x plus 1 over 10. Here's a chance for you to try one. I'm going to pause the video. Please try this example using the same logic, and let's see if you get it right. All right, guys, let's see how you did. If you picked cosine because of adjacent and hypotenuse, exquisite job. Then if you took the inverse of both sides after you plugged in 4 over x and got theta equals inverse cosine of 4 over x, if you remember to change that to arc cosine of 4 over x, you got it perfectly right. Okay, the last types of problems. Write an algebraic expression that is equivalent to the trigonometric expression. When you see something like this, it looks extremely confusing. When in doubt, I would always draw a triangle. Here's why. You know that this is always the reference angle because it's based on the x-axis. Arctangent. Arctangent, remember, means an angle that you're finding with the tangent function. So you're thinking opposite over adjacent. This is really x over 1. So if I had to draw a triangle to represent this situation, the angle could be found by doing opposite x over adjacent 1. So even though we have variables, we can still use the Pythagorean theorem to find the hypotenuse by doing this. 1 squared plus x squared equals, I guess I'll call it I don't know squared. 1 plus x squared equals I don't know squared. If we wanted to get my question mark alone, we would take the square root of both sides. So what I'm looking for could be represented as the square root of 1 plus x squared. So this is 1 plus x squared. Now, after all that work, are we done? Well, no. This helps me find my triangle, but now if I want to find the sine of what I just found of the composition, it based on the angle, sine of theta, this same theta, is opposite over hypotenuse, which would be opposite x over hypotenuse, the square root of 1 plus x squared. I don't think there's any reason to rationalize this, so here's my final answer. Last but not least, the last example of the unit. Let's draw a triangle again. I'm going to use this as the reference angle. We are saying that to find an angle, we are using the ratio of sine opposite over hypotenuse. So based on this angle, the opposite is really x minus 1 over 1. So 1 would be the hypotenuse, and x minus 1 would be the opposite. So we're going to use the Pythagorean theorem again. We're going to call this question mark for now, and I'll say what squared plus x minus 1 quantity squared equals 1 squared. Question mark squared plus x minus 1 squared equals 1. If I want to get this to the other side, question mark squared equals 1 minus x minus 1 quantity squared. If I want to get this question mark alone, I take the square root of both sides. So what I'm looking for is 1 minus x minus 1 quantity squared. We could simplify this, but I'm not going to at the moment. I want to find the secant now. First, if we found the cosine of the reciprocal, that would be what I just found. So this side is 1 minus x minus 1 quantity squared. So cosine is this mess all over 1. So that means that my secant is 1 over this mess.